Hello, sir. Good evening.
What we have learned in our last class,
We have learned the identities and the angle.
we had done last angle or related values of different trigonometric ratios,
Yes, sir.
means sine 30, sine 45, and so on.
Yes, sir.
Okay, suppose if someone asks you to find the value of sine 120 degree or for any different values related to any measurement. So how will you be able to calculate that particular value? I'm giving you some relation or rules. First, we divide the whole Cartesian plane into 4 segments like this. So this will be your first quadrant. This will be your second quadrant, third quadrant, and fourth quadrant. If there is a triangle in this particular first quadrant, like this, so it will have theta at this point. So corresponding to this particular theta, we would have base towards positive x-axis, perpendicular towards positive y-axis, and by calculating perpendicular and base, we will obtain hypotenuse of this particular triangle. Since base and perpendicular are in positive, so their square must be positive. So hypotenuse obtained would be positive in sign in this particular calculation. Okay.
Yes, sir.
Since all trigonometric ratios are related by these 3 parameters, so if we define trigonometric ratios related to this particular angle, which means between 0 degree to 90 degree, or just convert into the radian, pi by 2 radian. In between them, so all values should be in positive sign. So all are positive. Similarly, if we define a triangle in second quadrant like this, let's say theta for this part is this one. Base would be in negative x-axis, so where base will be in negative sign. Perpendicular will be in positive y-axis, and hypotenuse is defined by squaring these 2 terms, so it would be always positive in sign. So perpendicular and hypotenuse, their ratio would be positive. The rest of all ratio would be negative due to the base being in negative. Okay. So trigonometric ratios like sine theta and cosec theta, the reciprocal of that would be in positive sign. Rest of all term would be in negative sign. So we define sine theta and cosec theta for this particular quadrant going from 90 degree to 180 degree, or from pi by 2 to pi radian. Its values would be negative for all other trigonometric ratios other than sine theta and cosec theta. Similarly, if we define for third quadrant, tan theta and cot theta would be positive, the rest of all other would be negative. And similarly for fourth quadrant, cos theta and sec theta would be positive, the rest of all would be negative. So from this, we can conclude which of the trigonometric ratios would be positive in which of the different coordinate plane or Cartesian segment. Is it clear?
Yes, sir.
Okay. So by a simple rule, we can simply define different segment by simply knowing after school to college, by knowing this abbreviation. After means all, which is in first quadrant. S defines sine theta, which is in second quadrant. T defines tan theta, which is in third quadrant. And C defines cos theta, which is in fourth quadrant. Or you can simply learn add sugar to coffee. By any of these 2 statements, we can simply define which of the trigonometric ratios would be positive and which of the corresponding quadrant. Okay,
Yes, sir.
Yes, sir.
Khalid,
Assalamualaikum, sir.
walaikum assalam. Is it clear?
Yes, sir. Understood.
Okay, the next segment is how to convert from one trigonometric function to another. So we have two different rules. First is by knowing vertical line, and the second one is by knowing horizontal line. This is your pi by 2, and this is 3 pi by 2. If you move in this particular Cartesian plane in anti-clockwise, the angle would be positive, and while moving clockwise, the angle would be negative. So if you move from this point to left side this way, it would be pi by 2 plus of theta. Similarly, by moving this way in anti-clockwise, it would be 3 pi by 2 plus theta. But while moving clockwise like this, it would be pi by 2 minus theta. And similarly for this, it would be 3 pi by 2 minus theta. Here I have defined each of the four quadrants depending upon vertical line related with pi by 2 or 3 pi by 2. So this is conversion related to vertical line. In the next way, if I define by 0 or 2 pi or simply pi from this way. If you move in anti-clockwise direction, the value would be positive. So we can say 2 pi plus theta or simply theta. For this part in anti-clockwise direction, it would be pi plus theta. But if you move in clockwise direction like this way, it would be pi minus theta. And for this part, it would be 2 pi minus theta. So here, all of the four quadrants are defined on the basis of this horizontal line. So how we can use this particular conversion, I'm telling you that. First, for vertical line, sine changes into cos, cos changes into sine, tan changes into cot, cot changes into tan, and similarly, sec changes into cosec, and cosec changes into sec. But for horizontal line, there is no change. It means sine changes into sine, cos changes into cos, tan changes into tan, and so on. First of all, just write it down, this part. I'm coming in just 1 minute. Have you all written?
Yes, sir.
Eva,
Yes, sir.
just write it down. Well, it done.
Yes, sir.
Eva,
Yes, sir.
so if there is a question related to solving sine 120 degree, first of all, try to break this particular angle in relation with 180 degree or in relation with 90 degree. I'm solving you this particular part in both ways. Likewise, in relation with 1 degree, we can write this particular part as 180 degree minus 60 degree. Is it correct?
Yes, sir.
In this particular conversion, the first segment is 180 degree. This will only define in which line you are transforming or in which line you are converting. So this will define horizontal line. As we have discussed earlier. Okay, so next part is theta. So we can simply write this as on horizontal line, there is no change in any of the trigonometric function. So it will be written as sine of that particular angle theta. Is it correct?
Yes, sir.
The next part is to define whether this particular trigonometric ratio is positive or negative in that particular coordinate. So let's see, 120 degree would lie in second quadrant. And as we have defined, in second quadrant, sine theta and the reciprocal cosec theta would be positive. So by this way or by this convention, we can say sine theta would be in positive. So this would be plus sign. Now just write the value of sine 60 degree. It would be plus root 3 over 2. So sine of 120 degree is equals to root 3 by 2. Is it clear to everyone?
Yes,
Yes,
sir.
sir.
Similarly, if you want to calculate cos of 120 degree, so we convert this particular part in relation with 180 degree. So we can write it as cos of 180 degree minus of 60 degree. The first line or the first theta, that is 180 degree, would define just horizontal line or vertical line, which define the conversion of this particular trigonometric function. Since this is horizontal line and on a horizontal line, there would be no change in that particular trigonometric function. So we can write it as cos of 60 degree. The next part is to define whether this particular value would lie in which of the quadrant. So 120 degree would lie in second quadrant, and in second quadrant, only sine theta and their reciprocal would be positive. The rest of all trigonometric ratios would be negative. Here it is cos theta, so it would be in negative sign. Is it clear?
Yes, sir.
Yes, sir.
So it would be minus, and cos 60 degree is 1 by 2. So cos of 120 degree would be minus of half. Khalid, is it clear?
Yes, sir.
Just write it down and try to solve these questions.
So, sir, we have to do it all in one by 180 degree.
Yeah, just write this particular angle in relation with 180 degree or the nearest horizontal line angle.
Okay, sir.
Khalid, do you have any doubt?
No, sir.
Okay.
But, sir, I have a doubt. How do you
Yes, tell
get
me.
that minus or plus sign?
By simply defining in which segment or in which quadrant this particular angle would lie.
Okay, sir.
Suppose 150 degree would lie in second quadrant, and in second quadrant, tan theta would be negative, as we have only sine theta and cosec theta would be positive in second quadrant. So this tan theta would be negative. Okay.
Okay, sir.
Hiba, are you solving?
Yes, sir.
Any difficulty?
No, sir.
Okay. Should I solve? Khalid,
Yes, sir.
have you solved any of them?
Yes, sir. I have solved
Which one? First, second, third?
all of them.
Okay, good. Tell me your answer first.
Minus 1 by root 3.
Minus 1 by root 3. Second one,
Minus root 3.
minus root 3. Okay. Third one,
Minus 1 by 2.
okay. Hamza,
Yes, sir.
tell me your answer.
So minus 1 by 3, minus 1 by root 3.
Okay.
But sir,
Next part,
I didn't get the second one same as you.
tell me your answer.
So it is minus under root 3 by 2.
Okay. Third one,
So third one I'm doing.
Hiba, have you solved any one?
Yes, sir.
Which one?
First two.
First two. Tell me your answer. Is it the same or different?
First one is same.
Okay.
In one,
Second
I
is
got positive root 3 by 2.
good. Let me solve for the first part. Tan 150 is tan of 180 degree minus 30 degree. So 150 would define only horizontal line. There would be no change. So it would be tan of 30 degree. Since 150 degree is in second quadrant where tan theta would be negative, so it would be minus of tan 30 degree, which is equals to minus of 1 by root 3. So both are correct. For the second part, if we convert this particular to nearest horizontal line, it would be closer to 360 degree. So we can write this particular part as cos 360 degree minus 30 degree. So this particular angle would define horizontal line. On horizontal line, no change. So we can write it as cos of 30 degree. Since this angle would lie in fourth quadrant where cos is in positive, so it would be positive of cos 30 and cos 30 degree is equals to root 3 by 2. So both were wrong. Only Hiba has done correct. Okay, Hamza,
Yes, sir.
just solve third one. Khalid, have you seen your mistake? For the last part, break this particular angle as sine of 1 80 degree plus 30 degree. So this particular angle would be horizontal line on which there is no change. So it would be sine of 30 degree. But this angle is beyond 1 degree. So it will lie in third quadrant where sine theta would be negative. So we can write it as negative of sine 30 degree, which is equals to 1/2. Okay, Hamza?
Yes, sir.
Hiba done?
Yes, sir.
Okay, so for any different values of trigonometric ratio, we are now able to calculate the values. So just convert that particular angle related to horizontal line, which will be more easier as compared to changing in vertical line. As in vertical line, there is difference in trigonometric function as well as their angle. So it is easier to convert them in relation with horizontal line. Okay.
Yes, sir.
The next part is calculation for sum and difference of two different angles related to different trigonometric function. First formula is sine of A plus B. It is equals to sine A cos B plus cos A sine B. If there is negative sign at this particular point, it would be negative at this particular point. Now, if A is equals to B is equals to some theta, then this will become sine of 2 theta. So it will be sine theta cos theta plus cos theta sine theta. So it will become 2 times of sine theta cos theta. Just see in this particular relation, if there is twice of theta at this particular point, theta gets half and half at this particular point. So if we want to calculate sine of just theta, we can simply write it as sine of theta over 2 times cos of theta over 2. Is it clear?
Yes, sir.
Yes, sir.
Similarly, for cos part, if we have cos of A plus B, it would be cos A cos B minus sine A sine B. If there is negative sign in between them, so it would be positive. Now, if A is equals to B is equals to theta, it would be cos of twice theta, which means cos A cos B means cos of square theta minus sine A and sine B would become sine of square theta. Just convert these two parts into any one of them like this way. So it would be cos of square theta minus, we convert sine square theta in terms of cos as 1 minus cos square theta. So it would be 2 times of cos square theta minus 1 is equals to cos of 2 theta is equals to cos of 2 theta. So by this particular relation, we can simply write it as 2 times of cos square theta is equals to 1 plus cos theta. Similarly, for the next part, if we convert this particular cos square theta in terms of sine square theta, it would be 1 minus sine square theta minus sine square theta. Minus minus becomes 2 times. So it would be 1 minus 2 times of sine square theta is equals to cos of 2 theta is equals to cos of 2 theta. So if you want to calculate just sine square theta, bring this particular term to left side, and with to right side, it would be 2 times of sine square theta is equals to 1 plus 1 minus cos of 2 theta. Now, if we want to transform this particular formula into some other one, suppose we have 2 theta at this particular point. So theta at this particular point. If there would be theta at this particular point, it would become theta by 2. So we can write it as 2 times of cos square theta by 2 is equals to 1 plus of cos theta. Similarly, if we have theta at this particular point, So twice theta at this particular point. So if we can change this particular theta to theta by 2, it will become sine square theta by 2 is equals to 1 minus cos of theta. Is it clear?
Try to understand this one.
Any doubt? Hamza?
Yes, sir. From the beginning, I didn't understand this second one.
From which part? This part.
Yes, sir.
Suppose as we have sine of a plus b means sum of two different angle a and b. Similarly, if you want to define cos for sum of two different angle, there would be cos of a times cos of b minus sine of a times sine of b. This is just a formula related to the sum of two different angle and difference of two different angle. Okay.
Yes, sir.
Do you have maths and bio?
No, sir. I don't have bio. I have maths.
Okay. You must have learned chapter trigonometric ratios and trigonometric function. In
Yes,
that particular
actually,
chapter,
we
you will
have.
able to just define how this particular relation came to this particular part. Okay.
Yes, sir.
Should I derive this particular relation from where we have obtained this part?
Yes, sir. It will be easier to learn them.
Just write it down. I will just derive the whole relation, this particular part. Hiba, do you have maths or bio?
Sir, I have bio.
Okay. Khalid,
Yes, sir.
bio or maths?
Maths.
Okay. Have you all written this?
Yes, sir.
Khalid,
Yes, sir.
Hiba?
Done.
Yes, sir.
Okay. Suppose if you have y-axis, x-axis. There is a triangle at this point, and perpendicular is this one. I've drawn another perpendicular on this particular part as this and join that particular segment with origin like this. So we have two different triangles. First one is O, A, B. This one is your C. It is better to write it as P, Q, R. This would be your angle A. This would be your angle B. Here it is 90 degree and here it is 90 degree. Any doubt till now?
No, sir.
Okay. So from this particular part, we try to obtain first sine of A, cos of A, similarly sine of P, cos of P. Okay.
Yes, sir.
Suppose sine of A is equals to perpendicular over hypotenuse. So perpendicular is PQ, hypotenuse is OQ. Similarly, cos of A would be perpendicular base OP over hypotenuse OQ. Similarly, for sine of B, here B, which have perpendicular QR over hypotenuse OR, and cos of P is equals to base, that means OQ over OR. Is it fine?
Yes, sir.
Suppose I have drawn a perpendicular line from this point to this point, like this, and join this part to this. This is just construction. Okay, so we have this as B. So this whole would be 90 minus B. Similarly, here it has 90 degree. So if you just compare this triangle to this whole triangle, this angle would be equals to this part. Okay.
Yes, sir.
So instead of sine B and cos B calculating from this part, just try to calculate sine B cos B for this particular triangle and try to solve or try to evaluate related to this particular triangle. Let's say this as S, this as T. I think this would be quite more complicated. Just write it down. I'll solve it later.
Okay, sir.
How to start? Just write sine of A plus B. It means in triangle ORT. A plus would be total angle. So it would be perpendicular. That means RT over hypotenuse means OR. Is it correct? I have defined triangle OTR. In that particular triangle, the total angle is A plus B. So for that particular angle, I have defined sine theta is equals to perpendicular, that is RT over hypotenuse OR. Is it correct? You can transform this particular RT as RS plus ST. Divide by OR, divide by OR. Is it correct?
Yes, sir.
Now, we can write this RS over OR plus ST OR. In this particular part, RS is this base related to this particular triangle, related to the angle B, and OR is this particular part. So if we multiply and divide in this particular part as QR and QR, is there any change relating to this particular fraction? There will be no change. Similarly, if we multiply and divide by same term in this particular fraction, Suppose ST would be equals to QP, and OR is in this particular part. So we can write ST as PQ. So PQ upon OR. So if you multiply it by OQ and divide it by OQ, so we can simply write it as RS over QR into QR over OR plus PQ over OQ into OQ over OR. Is it clear to everyone till now
Yes, sir.
what I have
Yes,
done?
sir.
Now just see RS over QR. RS over QR is, in this particular triangle, cos of B is equals to base over hypotenuse, means RS over QR. Is it correct? So we can write this particular as cos of B into QR over OR. QR, this particular part, OR is this particular part, means perpendicular over base hypotenuse for the whole triangle. So it would be sine of angle B or A. I have written something wrong.
It should be B.
For this particular angle is perpendicular over hypotenuse. Okay, sine B plus PQ over QR. PQ means this particular part, perpendicular over hypotenuse OR. It means sine of A times OQ over QR. OQ is base over this particular part and OR is hypotenuse, means cos for angle B. So it would be cos for A. I think there would be A in this particular segment as this. Now it is correct. Is it understood to everyone? Should
Yes,
I?
sir.
How this would be A? Suppose this is your A. So this would be your 90 minus A. So this would be your again A. So this should be your 90 minus A, and this should be your A. This is 90 minus A. So this would be your A. This is your again 90 minus A. So this should be your A. Khalid, do you have any doubt?
No, sir.
Similarly, you can able to just find cos of A plus B, sine of A plus B, cos of A minus B, sine of A minus B by relating this particular triangle. Have you all written?
Sir, just the last part.
I have derived this particular relation just for your knowledge. There is no need to memorize this particular derivation. There is no use of it.
Done.
Okay. Khalid, have you written?
Yes, sir.
Hamza?
Yes, sir.
Okay. So by the same way, we have just derived a relation sine of a plus b as sine a cos b plus cos a sine b. Similarly, for minus sign, we can simply introduce minus to this part. If a and b are equal to each other, so that becomes theta. So it will becomes 2 theta. So sine of 2 theta becomes, these two becomes equal. So it becomes 2 times. So it will be 2 times of sine theta cos theta. Since it has twice of angle at this point, the angle gets half at this particular point. So if we write this particular as theta, it will become theta by 2. Okay. Similarly, for cos part, we have derived this particular term as a relation. Now, similarly for tan theta, if tan of a plus b. So divide sine of a plus b and cos of a plus b to obtain tan of a plus b. And on simplification, you would obtain tan of A plus tan of B divided by 1 minus tan A tan B. If there is negative sign in between them, so it will be negative and it will be positive. Now, if A and B are equal, means A is equals to B is equals to theta, it will becomes tan of 2 theta, which means 2 tan theta divided by 1 minus tan square theta. So we have derived sum relation and difference relation related to sine, cos, and tan. So if there would be a question to find sine 75 degree, next cos of 15 degree. So how would able to just calculate these values? Since we haven't learned about this particular part, we have learned earlier for 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. We haven't learned for 75 degree, 15 degree, and so on. So how to solve these particular angles? So it will be better to break this particular angle to the angle known to you, just as we can break 75 degree as 45 degree plus 30 degree. So this would be your A and this would be your B. And put the formula as we have discussed earlier as sine of A plus B. And on putting all values, we can define for sine 75 degree. Similarly, if we want to calculate cos of 15 degree, 15 is the difference of 45 and 60 or 45 and 30. So we can write it as cos of 60 degree minus 45 degree. Is it clear?
Yes, sir.
So here 60
So,
degree
sir, we have
would
to
be
use the
A.
formula.
Yeah. So 60 degree would be A and 45 degree would be B. As we have learned, cos of A minus B is equals to cos A times cos B plus sine of A times sine of B. Cos 60 degree is 1 by 2, cos 45 degree is 1 by root 2 plus sine 60 degree is root 3 by 2 and sine 45 is 1 by root 2. 2 root 2 is common to both numerator denominators, so it will be taken as LCM, so it will becomes 1 plus root 3. So this would be your required value related to cos 15 degree. You can simply let this particular term as it is, or you can simply rationalize the denominator. Okay,
Yes,
Yes,
sir.
sir.
Khalid, any doubt?
No, sir.
So we have obtained all the related formula, how to define values for all angle or different angle, whether they are multiple of 30 degree, 45 degree, 60 degree in relation with 180 degree and 360 degree, or we transform that particular angle as sum and difference of some known angles. And on putting the required formula, just try to solve their particular values. Just write it down. Have you all written?
Yes, sir.
Any doubt? Khalid,
No, sir.
Hiba?
No, sir.
Okay. So we have just finished all the topics related to the trigonometric section. The next and the most important segment related to mathematical physics is calculus. Why we define calculus? Suppose if we have a graph and there is a quantity which is changing like this, straight path. So we can say this particular coordinate y is changing linearly with x. So if someone wishes to find particular slope related to this particular line, so just put some coordinate at this point, coordinate at this point. So let's say it would be x1, y1, and could do x2, y2. For slope is the ratio of perpendicular over base, or simply tan theta of that particular line. So just proceed this particular line to this point. So this will define theta. So this would be your perpendicular and this would be your base. So slope for this particular measurement is denoted by m, or simply is equals to tan theta, which is equals to perpendicular over base. For perpendicular, just difference the y coordinate of two different points. So it would be y2 minus y1. And for base, it would be the difference of x coordinate of these 2 points. So it would be x2 minus x1. So by knowing x1, y1 and y x2 y2, we will be able to find slope theta of this particular line or the inclination of this particular line related to x-axis or y-axis. Okay.
Yes, sir.
The next part we wish to calculate for this particular line is area inscribed by that particular line with respect to x-axis. So let's say it is like this. So drop this particular line to x-axis. So the area inscribed would be like this, or it is depicting just trapezium. So the area of trapezium is half sum of parallel sides and perpendicular separation between them. So it would be area is equals to half sum of parallel sides, which means this segment and this segment. Let's say this as y1 and y2. So it would be y1 plus y2. And the difference of these two segments, which means x2 minus x1. So this will define area related to that particular curve, and this will define slope related to that particular curve. So there is no much difficulty in these two calculations. Now, suppose if you have a curve, not a straight line, like this. So the question arises, how we define slope of this particular curve, or how we would able to calculate area inscribed in this particular curve with respect to x-axis. So we use a mathematical term which is called calculus. Okay, so calculus is nothing but mathematics related to any curve or any line. It is applicable for both curve as well as straight line as well. So just write it down. Then I will start this particular section. This is just area of trapezium. All have written?
Writing a trapezium.
Okay. Khalid, do you have doubt? Hiba, any doubt?
No, sir, no doubt.
No, sir.
Okay. Have you all written?
Yes, sir.
Yes, sir.
Okay. So now, since for a straight line, The inclination of this particular line with respect to x-axis would be constant at each different point. But for the curve, there would be different inclination of this particular curve at different instant of time. So it will define that it would have different slope or different inclination at different point of inclination. Suppose I have drawn a line at this point. Similarly, if I drawn a line at this particular point, so this particular tangent will define slope of that particular curve at this instant of time, slope of the curve at this particular point of time. So there is different slope of the curve at different instance of time. So how you would be able to calculate that particular slope or simply change of vertical component with respect to horizontal component related to this particular point and related to this particular point. For this, we have a branch of calculus which is called differentiation or derivative. So let's define differentiation, or simply it is called derivative. Let's say we have a curve like this. So if we draw a line pointing or joining two different points like this, it means it will have some coordinate at this particular point. Let's say it would have some x coordinate and y coordinate. Let's say this as x1 and this would be as x or y simply. This is your x and this is your y. Similarly, for this point, we have draw a vertical line over this. There is change in this particular coordinate to this particular change. Let's say it has delta x. So the total coordinate resembling with origin, it would be x plus delta x. Is it correct?
Yes, sir.
Similarly, if we define this particular change as delta y, so the total length from origin would be y plus delta y. In this particular term, we have just joined a curve by two different points or a line which is touching this particular curve at two different instant of time. We wish to bring this particular point more and more closer to the original point so that this line would tend or act as tangent to this particular curve. Since a tangent touches the curve at single point, so it will define slope or rate of change of the curve at any given instant of time. Is it clear?
Yes, sir.
Yes, sir.
As we have seen, this particular line is touching the curve at two different points, so it will be called as chord. I wish to bring this particular point more and more closer to the original point so that this particular line would tend to or behave as tangent to this particular curve. And a tangent touches the curve at single point, so it will define slope of that particular curve at any given instant of time. So for that particular process, if I have shrink that particular term like this, again, at this point, and again at this point. So in this whole process, I have just bring this particular point more closer to the original point. it means I'm decreasing this particular delta x tends to 0 so that this point would exactly overlap on the original point. So the line which was initially being or behaving as chord would now act as tangent. So now the tangent would touch this particular curve on a single point. So it will define tangent or the slope of the curve related to any given instant of time. Okay. So this process of reducing this particular term is just changing, or we have taken slope is equals to perpendicular over base. Now we have defined a limit related to that particular change delta x. Limit delta x tends to 0, del y over delta x. It means we are bringing this particular point more and more closer to the original point such that this change would act very small or which is called infinitely small segment. So the ratio for the change of that particular term, this would read as dy over dx. Is it clear?
Yes, sir.
Yes, sir.
So what actually differentiation means? It defines the rate of change of y with respect to rate of change of x. Here, suppose if we can write y in terms of x, like y is equals to 2x plus 5. So we can say y is just a function of x. Okay. So here
Yes, sir.
x is called dependent variable and y is called independent variable. If we change the value of x, the corresponding of value of y would be changed. So we can define this particular term as the ratio of change in variable y with respect to change in variable x, such that the change of x is very small, or it is called infinitely small change. Then that particular ratio or that particular relative change in respect to one coordinate with respect to another is called differentiation. Okay, so differentiation actually means the change in one coordinate with respect to another, such that the change is infinite small, which means delta x tends to 0. Okay. Then this particular relation is called differentiation of y with respect to x. So this particular differentiation would define you the equation of tangent related to this particular curve. It has another geometrical concept, which I will explain later. Any doubt till now?
No, sir.
Just write this. Khalid, any doubt?
No, sir.
Okay.
So what is written there? Delta y near that delta y by delta x.
Slope is equals to del y over
No,
delta
sir.
x.
Down. Sir.
Limit. LIM is the abbreviation or short form of limit. Limit means we are just bounding the value of delta x, which should be very small, or it is simply called infinitely small.
Okay, sir.
Sir, what is written in the last line?
Such that the change is infinitely small,
Okay, sir.
infinitesimal small.
Okay, sir.
Have you all written?
Yes, sir.
Khalid? Khalid,
Yes, sir.
have you written?
Yes, sir. Done.
Okay. There is another aspect or another way of solving this. Suppose you have a curve like this, and we have just drawn a line by joining these two different points. So it will represent the change related to this point and this point in comparison with x and y as well. So if we wish to break this particular change in more and more smaller part, so we can simply break this particular line more closer like this. So it will define the change over this particular part to this part. If we again move to more closure, like this point, infinitely small change for this part. So in this segment, this line would tends to become at this point. For again this particular change, it will become just straight touching just a single point. So differentiation actually means breaking of a curve into an infinitely small strip such that it will act as single point. So if we draw a tangent to that particular point, it will define slope of the curve at that particular instant. Okay.
Yes, sir.
So these are just geometrical concepts related to this particular differentiation. How we actually do for that, we have certain formula. First, if y is equals to x raised to the power x n, where n is any numerical part, x and y are two different variables. So the differentiation of y with respect to x, so we can read it as dy dx, or the differentiation of y with respect to x. It is not just a ratio, it is just a respective measurement of one coordinate with the change in measurement of another. So it will be just bring this particular exponential to the coefficient n times of x and reduce the exponential by 1. This is your first formula related to differentiation. Okay.
Yes, sir.
Suppose for this, if you have y is equals to x cube, and you have to, or you have asked to differentiate this particular term with respect to x. So just write dy over dx. The rule is bring that particular exponential to the coefficient part. That means 3 times of x, and reduce the exponential by 1. So it will be 3 minus 1. So your answer would be 3 times of x squared. If there would be y is equals to 1 upon x squared. So bring all the exponential to the numerator first. So we can write it as x raised to the power minus of 2. Now apply the above relation. So it would be dy over dx is equals to nx n minus 1. So it will be minus of 2 x raised to the power minus 3 or you can simply bring this particular term to the denominator to make this particular coefficient exponential positive. So it will be minus of 2 over x cube. Is it clear to everyone?
Yes, sir.
Yes, sir.
So the first formula related to the exponential function is if y is equals to x to the power n. So the differentiation would be bring the exponential to the coefficient and reduce the exponential to the by minus or by 1. So write the all term first in numerator and just apply this above expression or above formula to the each one. There is another formula if y is equals to any constant number. Let's say y is equals to 5. Okay. We can write this particular 5 as 5 into 1, as 1 is the multiplicative identity of each number. Okay. Is it correct?
So can you
Khalid?
explain it again?
Yes, sir.
Suppose y is equals to any constant and we have to differentiate this particular part. So I have assumed this particular constant to be 5. Okay.
Yes, sir.
So suppose y is equals to 5. So we can write 5 is equals to 5 into 1, as 1 is multiplicative identity of all number.
Yes, sir.
Okay. This particular one can be written as x raised to the power 0, as any expression to the power 0 is equals to 1. Okay.
Sir.
Now we have y independence with x and 5 being coefficient. So apply differentiation dy dx, bring the coefficient forward and apply differentiation formula to this particular exponential. We have exponent as 0. So by applying this particular formula, it would be nx n minus 1. So it would be 5 into 0 times x raised to the power minus 1. And 0 multiplied with any number but becomes 0. So we can say the differentiation of any constant term gives you 0. Okay.
Yes, sir.
Is it clear? Hiba?
Yes, sir.
Khalid?
Yes, sir.
Okay, just try these two formula. All have written? Hamza?
Yes, sir.
Khalid?
Yes, sir.
Yes, sir.
Okay. So there is another concept. How we define differentiation for different operations. If y is sum of two different functions or just difference of any two different functions. So differentiating, it will be differentiate each function individually plus or minus differentiate each term individually. There is no impact of one function on other in addition and subtraction. So this is your first formula. But in multiplication, if y is equals to fx dot gx, there is a multiplication in between them. So we use product rule, which state dy dx is equals to differentiate first part and multiply it by second plus differentiate second part and multiply it by first. This is called product rule. Next is if y is fx divided by gx, means they are in division. So dy dx is equals to differentiate first part fx, multiply it by second, minus in product we have plus sign. So in division we have minus sign in between them, differentiate denominator and multiply it by numerator and whole divided by square of denominator. Any doubt till now?
No, sir.
So we have three different formula related to the operations. Suppose for sum or difference, just differentiate each part individually. There is no impact of one on other. But for the case of product rule, suppose if we have two different functions which are multiplied by one another. So on differentiating, differentiate the first part and multiply it by second one, plus differentiate the second part and multiply it by the first part. Similarly for the division part as well, differentiate the numerator and multiply it by denominator, minus differentiate denominator and multiply it by numerator, whole divide by square of denominator. How we will use this particular function? I'm giving you some examples.
So
Suppose
fx and gx are
two different
any number,
functions,
like
two different functions,
okay.
function of exponential, sine, cos, tan, or any other term.
Okay.
So if you have sine x, its differentiation would be cos x. Since this is your y, so its derivative would be cos x. If there is cos x, its differentiation would be minus sine. Exponential e to the power x, it would be e to the power x, and log of x, it would be 1 over x. Okay, just try this all. I'm giving you some example relating all these concepts.
Sir, can you explain again what is that EX and log X?
Ex is exponential function and log x is logarithmic function. We should learn in our next class, inshallah. Okay. After calculus, I will teach you these two sections, exponential function and logarithmic function. Here, just remember that differentiation of ex remains ex and differentiation of log x becomes 1 by x. Have you all written?
Yes, sir.
Hamza?
Yes, sir.
Khalid?
Yes, sir. Done.
Okay. Suppose if there is question y is equals to 1 over x minus sine x plus pi, and we have to differentiate this particular part. So first, bring whole term or each part to the numerator. So we can write this as x raised to the power minus 1. This is your first function. Next is minus of sine x is the next function, and plus pi is the next one. So we have mainly 3 different functions in this particular problem. So according to the rule of differentiation, for any function which are related to each other by sum or difference, just differentiate each part individually. There is no impact of one over the other. Okay. Likewise, if we want to differentiate this particular function, the first function is exponential. We have a rule for exponential if x raised to the power n. So differentiation tells you bring the exponential to the base and reduce the exponential by 1. Here we have minus 1 as exponential, so it will be minus of 1 times x minus of 1 minus 1. Is it clear?
Yes, sir.
What is your next function? This is trigonometric function sine. We have a formula for this. For the differentiation of sine, it will be cos of x. Okay. So for the differentiation of
Yes, sir.
sine, it will become cos of x. Next part is pi. Pi is any constant number. So we have just defined the differentiation of any constant term, what gives you
0.
0. Okay, so we have pi as any constant term. So on differentiating, it will become 0. So just simplify this whole term. So it will be minus of 1 over x square minus of cos x. This will be your differentiation of this particular function. Is it clear? Hiba?
Yes, sir.
Yes, sir.
Khalid?
Yes, sir.
Okay,
Understood.
good. Try to solve if y is equals to root of x plus x cube minus e raised to the power x. Try to solve. Try to solve. I'm coming just in 1 minute. Hamza, any doubt while solving?
I solved a bit. After that, I don't know what to do.
First one,
Yes, sir.
what you have written for root of x.
X by 2.
First, write it in exponential. So it would be x raised to the power. This would be your x raised to the power q, and it would be e raised to the power x. Okay.
Yes, sir.
Now apply differentiation rule. It states for any exponential function, bring the exponential to the coefficient, so it will becomes half x, and reduce the exponential by 1, so it will be half minus 1. Is it clear?
Yes, sir.
For the next part, we have x raised to the power q. So bring the exponential 3 to the coefficient and reduce the exponential by 1. Similarly, for the third part, we have e raised to the power x. There is no change in differentiation of exponential function, so it will remain e raised to the power x. Now simplify this particular part, you would obtain required result. Hiba, do you have a doubt?
Yes, sir.
No, sir.
Do you have any doubt, Khalid?
No, sir.
Anyone has done second question? On simplifying, this will become 1/2 x raised to the power minus half, or we can simply write it as 1/2 x raised to the power plus half, or we can simply write it as under root of x. This will become 3 times x squared, and this will become e raised to the power x. So this will be your final result. Have you tried the second one? Anyone?
Sir, we have to use that product rule, right?
Yeah. So this will be your first function, that would be fx, and this would be your second function, that is gx. Apply that product rule. Hamza, have you done second question?
So do we have to use anything in place of d by dx?
Just ask again.
Do we have to use anything in place of d by dx?
No. In left hand side, we have to just differentiate this particular term. So we can write as dy over dx. It means differentiation of pi with respect to x. So we have two different functions which are multiplied by one another. So it states differentiate first part, that is x square, and multiply it by second one, plus differentiate second part and multiply it by first one. Okay.
Yes, sir.
Now, just apply the rule. Since it is x squared, so on differentiating, bring the exponential to the coefficient as it is exponential function or exponential. So we have 2 times of x, reduce the exponential by 1, multiply it by sine x, plus differentiation of sine x is cos x, and multiply it by sine x. Just simplify this, so it will become 2 times of x times sine x plus x squared times cos x. So this will be your final result. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay, just write it down. Khalid, do you have any doubt? Have you all written?
Yes.
Yes, sir.
Okay. I'm giving you another problem. Suppose if someone asks you to differentiate tan, cosec, sec, suppose y is equals to tan x, and we have to differentiate this particular function. And since I haven't written you the formula related to tan x, cosec x, sec x, cot x in this particular relation, so how would you define? So just break this particular trigonometric function into some known function like sin x over cos x. Okay. Now this will become as two different functions which are related in division form. So it will be a numerator and it will be a denominator. So apply quotient rule for this particular function and try to obtain the result. Okay.
Yes,
This
sir.
would be your fx. This would be your gx. Try to apply quotient rule and try to solve. Better just first write your formula related to that particular function and try to put the different values of fx and gx related to that particular relation. Suppose in this particular term we have quotient rule, so we can write dy dx is equals to differentiation of the fx first function times denominator minus differentiation of denominator multiplied by numerator whole divided by square of denominator. Now put the values of fx and gx in their respective positions and try to solve. Hamza, are you facing any problem?
So do we have to change these values?
Which one? fx, gx, which one?
Because I have written like sin x into cos x minus cos x into sin x.
No, just
So
put
do we
this
have to,
particular value of fx as sin x in their respective position. So we can write it as d over dx of fx. It will be like this, multiplied by gx minus differentiation of the second part, that means cos x, multiplied by fx, which means sin x, and whole divided by square of denominator. So it will be cos of this. Is it clear to everyone?
yes, sir.
Now, this would tells you the differentiation of sin x. So we have learned a relation. Differentiation of sin x was cos x and differentiation of cos x was minus of sin x. Okay,
Yes, sir.
so just try to put differentiation of sin x would be cos x multiplied by cos x minus differentiation of cos x is minus of sin x multiplied by sin x whole divided by square of denominator. Is it clear?
Yes,
Yes,
sir.
sir.
Now this becomes cos and cos means cos square of x minus and minus plus sine into sine becomes sine of square x divided by cos square x. So we have learned an identity sine square theta plus cos square theta will give you 1. Okay,
Yes, sir.
Yes, sir.
is it the similar one? Sine square x and cos square x.
Yes, sir.
So it will gives you 1 over cos of x square.
Yes, sir.
1 by cos is sec square of x. So we have obtained that differentiation of tan x is just sec square x. Khalid, any doubt?
No, sir.
Okay, just write down.
Done, sir.
Okay. Hiba done?
Yes, sir.
Khalid?
Yes, sir, done.
Okay. Similarly, if you want to calculate or try to differentiate sec x, so we can write this particular sec x 1 over cos x. So here 1 would act as fx and cos x would act as gx. Use question true and try to obtain or try to differentiate this particular function. Just proceed as we have done previous question. Any difficulty in solving?
No, sir.
Hiba?
No, sir.
Okay. Should I solve? Hamza?
Yes, sir. So I'm a bit confused in the last step.
Khalid, have you done?
Yes, sir.
Tell me your answer.
Tan square x.
Okay. Let me solve. We have fx as 1 and gx as cos x. So dy dx would be differentiation of fx multiplied by gx minus differentiation of denominator multiplied by numerator gx and fx whole divided by square of denominator. So now put these values. Fx is 1, so differentiation of 1 multiplied by cos x minus differentiation of cos x multiplied by 1 whole divided by square of cos square. Any doubt?
No, sir.
Okay. Next, since 1 is any constant part, so the differentiation of that particular constant would be 0, and 0 multiplied with a number would be 0. Okay.
Yes, sir.
Next, minus differentiation of cos x minus sine multiplied by 1 divided by cos square x, which means cos x into cos x. Now, minus minus becomes plus, so we can write 1 into sine x divided by cos x into cos x. So this part will give you 1 over cos, which means sec x, and sine over cos means tan x. So your result would be sec x into tan x. Khalid, I think he was right. Hiba, any doubt?
No, sir.
Okay, just write it down. And try to learn all different concepts related to this particular differentiation and try to solve all the different problems which we have discussed in this particular class. Okay, Hamza?
Yes, sir.
Written?
Yes, sir.
Hiba, done?
Yes, sir.
Okay then, just stop here. We'll meet in next class and we'll try to find different problems related